Okay, got some extra examples of two-step equations. Again, optional video. You can fast forward if you want to. Okay, I'm going to start off with some algebra tiles. Okay, so this is some extra examples. Again, I'm starting with algebra tiles. If you've never seen algebra tiles before, quick explanation. The two big rectangles here are positive x's, two positive x's. I also have two positive constants, okay? And that all equals 6 over here. So two unknowns, okay, same amount of value, plus two more is equal to 6. Okay, so I'm going to use this just to kind of show you, and then I'll explain to you why I don't normally use algebra tiles for the rest of them. All right, so if I look at this here, I say, look, this is like I gave two envelopes to someone with the same amount of money, $2 extra, and I'll tell you that all of this is equal to 6. So some of you might be able to see the answer already, but I'll show you what I'm going to do here. So, whoops, I'm going to make a mess is what I'm going to do. Here you go. So there's that. What I'm going to do is I'm going to try to eliminate, I want to get this all by itself. I'm going to eliminate these two here. So what I do is I had the 2x plus 2 equals 6. And what I'm going to do is I'm going to subtract 2 from both sides. Okay? If I subtract 2 from both sides, I'm going to take those 2 away. And there's 2 here to take away from here. So I eliminate those. If I eliminate 2 from both sides, you'll notice here that I'm left with 2x. And over here I'm left with 4. Okay, so far, so good. I'm just going to scoot this down a little bit. Let's put it right there for now. Okay, so if I eliminate that, I got that. So that's great, but I don't want 2x. I just want 1x. So if I divide this by 2 and divide that by 2 to both sides, I'll split those up here, and I split these up. I can easily see here that one of the x's, one of the unknowns, is equal to 2. All right, and so that's what was in the unknown. I could double check my work. 2 times 2 plus 2, does that equal 6? And I could tell you that yes, it does equal 6. Check. Now, the reason I don't necessarily always use algebra tiles, I think that's a good way to start off. Reason I don't do that is for the following reason. Imagine I had a question like this, where I had to come up with 6 x's, 15 negative signs, and 33 of these. Boy, that would just take up a lot of room. So instead of doing that, I go ahead and just start solving it. I say, look, here's my variable term. It's saying 6 times x subtract 15 equals 33. So I'm going to undo this by going the opposite of PEMDAS, right? Take care of any addition or subtraction first. Another easy way to do is cover your variable term and say, hey, that's what's left. Take care of that. So I'm going to add 15 to both sides. The reason I add 15 is because that eliminates this over here. This drops down. I still get 6x eliminated. And I add this together, which gives me 48. Okay, that's what I want. I want to start getting the x term, the variable term by itself. Then I say, okay, I took care of addition or subtraction. Now I'm going to take care of multiplication. I do that by dividing by 6, the inverse operation. I find out that x is equal to 8 is my answer. And then, of course, I want to double check. 6 times 8 minus 15, does that equal 33? Well, that's 48 minus 15, and sure enough, that does equal 33. All right, let's do a couple more practice problems. Okay, here's another one. Negative 7y plus 3 equals negative 25. Let's figure out what we do here. All right, so I like drawing a little line to say, hey, there's the left and right side of this equation. Here's my variable term. Okay, there's going to be some multiplying that I got to get rid of, but first take care of the addition or subtraction. So in this case, it's plus 3, so I go minus 3. I'm always doing the opposite, right? I'm unrolling this equation. All right, so I'm going to go ahead and cross those out. This just drops down, and I get negative 7y is equal to negative 28. Remember, two negatives combined give me more negatives. I then can divide by my negative 7, and I find out that y is equal to, let's see, it goes in 4 times. Positive 4 because a negative divided by negative is positive. Then I'm going to check my work. Negative 7 times 4 plus 3, does that equal negative 25? Question mark. Well, this is negative 28 plus 3, and sure enough, yes, it does equal that. All right, let me try one or two more challenging questions. All right, here we go. Okay, 15 minus 1/2 times b equals negative 3. So you're thinking, minus. You said minus right here, so don't I get rid of that by adding? Well, really, think about the terms. This is positive 15. This is negative 1/2 times b. So this is times. Again, a good clue is cover up your variable term, and that'll tell you, if I cover that up including the sign, that'll tell you that, hey, keep that here for right now. Get rid of this guy, which in this case is a positive 15. So I'm going to subtract 15 on both sides. Okay, and remember, eliminate your constants first. That'll cross out. This drops down. I get negative 1/2 b is equal to negative 18. All right, so that's a good start. Got rid of my addition or subtraction. Next, my variable term is still being multiplied by 1/2, or negative 1/2. So in this case, I'm going to take that and multiply by negative 2 over 1, the multiplicative inverse, if you recall the name of that. That crosses out, that crosses out. That leaves me with the b. This over here, negative times a negative is positive 36. And so I'm going to go back and check to see if I got that right. Let's see. 15 minus half of 36, does that equal negative 3? Well, let's see. It's 15 minus half of 36 is 18. And sure enough, 15 minus 18 gives me negative 3. All right, I'm going to give you one last example. All right, how about this bad boy here? Okay, let's see if you figured it out. What do I do first? Well, not the multiplication. Get rid of this positive 25. So I'm going to subtract 25 on both sides. This crosses out. That drops down. Positive 11/12 times b is equal to, and I can subtract here, 22. All right. Next, I get rid of the multiplication by this time. I would be dividing by a fraction, so that means use the multiplicative inverse. Right? Those are cross out. That crosses out. I get b equals, I'm going to do some crossing out on my own over here, 24. That's what I think b is equal to. Okay, so if I think that's the answer, let me go back and check my answer. 11/12 times 24, does that equal 47? 24 over 1. Let's see. 25 plus, let's see, I can do some cross canceling. 22, does that equal 47? Question mark. I'll do one more step here. Yeah, 47 does equal 47, so ta-da, that is my answer. All right, so hopefully you got a little bit of the easy stuff, a little bit more difficult stuff, and come ready with questions if you need to.